Okay, so we're going to talk through the circles test here. Obviously, don't spend time listening to questions that you already got right. Go to the questions that you didn't and make necessary corrections there. Yeah, let's see. So our first question, we've got to find the area and perimeter of a quarter circle. Now, in general, if we want to find the area of one of these things, then it's going to be the fraction, so in this case that's a quarter, times the general area of a circle, so pi r squared. In this question, the radius is 6, so we're going to use that as our radius. We're going to say we need to do a quarter times pi times 6 squared. Type that all in, round that to 2 decimal places, and you get yourself to 28.27, rounding to 2 decimal places because the question says to do so. Centimeters squared, don't forget your units as well. For perimeter, we're still going to do a quarter of the circumference, so a quarter of pi d, and then we're going to add the diameter essentially, so the 2 6's there at the end. So what do we need to do here? We need to do a quarter times pi times diameter is 12, and then also plus 12 at the end because we want the 2 straight sides as well when we're talking perimeter. Again, rounded to 2 decimal places, that will give us a total of 21.42 centimeters. Okay, question 2. So question 2 is we want to find the value of x on this circle. So what I would do is you're given the area. We know that area equals pi r squared. So in other words, 10 is equal to pi r squared. So we want to divide by pi to get r squared, and then we want to square root that to get what r actually is. Put that together and we'll get that r is equal to 1.784 or thereabouts. And then we look at the question, and x is actually the diameter, so x is double the radius. So we need to times it by 2, and we'll get that the value of x is 3.57 centimeters or thereabouts. Doesn't say how to round it, so that would do. Okay, a piece of wire is put in the shape of the semicircle of radius 20. We want to find the perimeter of this shape, and then we want to find the area of the square. Let's actually zoom in a bit so I can be a bit more precise with these drawings. So perimeter. So this is a semicircle, so we're going to need to do a half times the circumference plus the diameter, and we know that the radius of that semicircle is 20, so that means the diameter of that semicircle is 40. So we can go half times pi times 40 and then plus 40 as well. And we can put that all together and we can get a value of 102.83 centimeters. Now, the question here is that the wire is then twisted into the shape of a square. So that means we would have a square where we've used all that wire and we've got ourselves a perimeter of 102.83 that we've already worked out. So what do we need to do? Well, if all 4 of these sides together add up to 102.83, then just one of those sides, let's call it A, would be equal to that perimeter divided by 4. Divided by 4, that'll give us about 25.7 for one side of the square, and then if we want to get the area of the square, we're going to need to multiply base by height, so 25.7 times 25.7, and that would give us in the region of 660.9 centimeters squared. So yeah, you had to realise that if you're changing the perimeter into perimeter of a square, you need to divide by 4 to find one side length. Okay, ice rink. This is another perimeter question. We want to find the distance around the outside of the rink. and that consists of a semicircle here and a semicircle here that overall make up one circle. So we need to do pi d for the circumference there, plus the 200 meter top and bottom of the ice rink. So that's our calculation that we're going to need to do. Diameter of the ice rink is 80 because the radius is given as 40. So we need to do pi times 80 plus 200. And so overall, the distance around that rink would be 451.3 meters, or thereabouts. It says that the floor is replaced at a cost of £50 per square meter, and we want to know how much this costs. So what that means is we need to find the area of the whole shape, and the area is going to be a rectangle, that's in the center, plus, well, two semicircles, but we could just put those two together and just say this is the area of a rectangle plus the area of a circle. Like you can combine those two semicircles together. So for a rectangle, we need to do base times height, so that's just 80 times 100. For circle, you need to do pi r squared, and radius is 40, so pi times 40 squared. Put all that together and you should get that the area of the ice rink is 13,026 meters squared. This is going to be a very expensive replacement, and it costs £50 per meter squared. So we're going to need to times that by 50. It's going to be an enormous cost of £651,327 and 41p. Now it does say to the nearest £10, so we should round that as being equal to £651,330 or thereabouts. Okay, let's keep going. Question 5. Area of the square is 64. We'll need to find the area of the circle in terms of pi. So square is just base times height is equal to 64, and we know they're the same thing in fact, so we just know that whatever this length is here, let's call that x, that's equal to 64. So we just need to square root it, or just think, well, what times is by itself to give you 64, and that would tell you that the length of that square is 8. Obviously the height of that square will be 8 as well. We want to find the area of the circle. Now if all the way across is 8, then halfway across is 4. And so the area of the circle would just be pi times r squared. So pi times 4 squared. 4 squared is 16, so just 16 pi. Realistically, we should have units on here and say 16 pi centimeters squared. Okay, let's keep going. Square contains 4 equal circles. Find the shaded area. So to find that shaded area, we need to do the square area minus the 4 circles. So one way you could do this is you could obviously find the area of a circle first, times it by 4, or we could plug it all together. So the square is 12 times 12. Now the circle, that's 6 centimeters across, and that more importantly means the radiuses of these circles, because they're all equal circles, is 3. So for our circles we're doing 4 pi r squared, and our radius is 3, so 4 times pi times 3 squared. This time it wants it rounded to the nearest whole number, so if we type all that in, we're going to get 30.9 centimeters squared. Rounding to the nearest whole number would give you 31 centimeters squared as your final answer. And that's our shaded area. Okay, what about 7? A wheel of diameter 60 travels 1.6 kilometers. How many times does it fully turn around? So I said look at the units here. That's because this is centimeters and this is kilometers, and we kind of want to compare them. What I did was I would change them both to meters. So meters, the wheel has a diameter of 0.6 meters, and there are 1,000 meters in a kilometer. This will be 1,600 meters. Now what do we need to do when we say like a wheel turns all the way around once? Then what it's doing is it's using its circumference exactly once. So we need to know the circumference of this wheel, and that's equal to pi d. So pi times 0.6, because again we're told the diameter was 60 centimeters. That's going to give me like 1.885 ... meters, and then I just need to see how many times that fits into the 1,600 meters that we need it to travel, and that should be the number of times that it needs to spin around. So if we divide 1,600 by our answer, we'll get that it has to spin around 848.8 times. And so how many times does the wheel fully turn around? So we'd say 848. If you've ended up rounding that up to 849 and saying, well, it's got to actually travel the full 1,600 meters, I've got no problem with that either, but I think 848 is technically the answer we should have. Okay, last page. Motor race must cover at least 200 kilometers. How many full laps of this track are needed? So what we need to know is what one lap is equal to. And one lap consists of two straight sides, so it's got a 0.75 along the top and a 0.75 along the bottom. Then it's got half of a circle here, so that's half a circumference we need to add on, so half pi, and then the diameter there would be 0.9. And then it's got these three little wheels. Now it's useful to think about what the diameter of one of these little wheels would be, because we can see that we've got 0.9 kilometers that's been split into three bits. So each of the diameters of these little semicircles should be 0.3. So we're also going to have to add on 3 lots of, because there's 3 of them, a half times pi times 0.3, and that will cover our 3 little semicircles, and that'll be the entire way around the track. So we're adding the 2 straight bits of 0.75 each, we're adding 1 big semicircle and 3 little semicircles. So if we put it all together, we'll get 1.5 for the 2 flat bits, we'll get 1.414 for the big semicircle, and we'll also get 1.414 for the 3 little circles all added together. I think each of them is worth like 0.47. If we add that all up, we're going to get that all the way around this track is 4.327 ... kilometers. And we want to know how many full laps of the track are needed to travel 200 kilometers, so we need to divide it into 200 and see how many times it goes. And that will tell us that it goes around 46.21 ... times. So how many full laps does it need to do? If it needs to cover at least 200 kilometers, you'd need to round up, and then we'd need to do 47 laps. Interesting question, that. Okay, and then we have a little bit of a price comparison. So we've got OK Year, 0.8 meters, and replaced every 15,000 spins, and Flame Rock, radius of 0.45, replaced every 12,000 spins. So what we need to know is how many times the tyres need to get replaced during one of these races. Now one of these races is obviously 200 kilometers. And this is quite similar to a question we had over the page where it was like, find how many times it spins round. So let's do OK first. The OK one's got a diameter of 0.8, so they've got a circumference of pi times 0.8, and that would be 2.51. And then they get replaced every 15,000 spins. So we're going to need to multiply that up by 15,000. And we'll get that they need to be replaced every 37,699 meters, because the diameter was in meters. If we look at Flame Rock, their circumference is equal to pi times 0.9, because the diameter is 0.9 in that case. If the radius is 0.45, you double it. That's 2.83 or thereabouts, and they need to be replaced every 12,000 spins. So we need to times that up by 12,000, and we'll get that they get replaced every 33,929 meters. So the question would be how many times you have to replace it in a 200 kilometer race. So 200 kilometers, if we times by 1,000, that's 200,000 meters. And what we're basically saying is, well, how many times does this divide into it? So if we go 200,000 divided by 37,699, we'll get that this will need 5.3 tires, and we'd have to round that up, obviously. So it need to be replaced at the end of every one of those. Actually, yeah, so 5 tire replacements, wouldn't it be? Yeah, because you've still got it. You still got your original tires on. So we kind of round down on this one. Whereas the Flame Rock ones, we want to do 200,000 divided by 33,929. And that's going to be 5.89. So again, that would only need 5 replacements. So what choice would mean the fewest number of tire replacements? We can actually say neither. They would both require 5. You could make a slight call for OK year being better, because it's less close to another replacement. That would have to be it, and we'd have to say 5 replacements each. I thought that was quite a tricky question, by the way, so well done if you got anywhere with that one. Speaking of tricky, here's the challenge. So it says to find the area of this part of a circle, and so far what we've been doing for like a half circle is we go like a half times pi r squared, or for like a quarter circle we go with a quarter times pi r squared, and generally if we've got a fraction of a circle we say a fraction times pi r squared is what we need to do. Now what fraction of a circle is this? Well, this is 110 degrees, and if you think about it, all the way around would be 360. So the fraction of a circle that we've got there is 110 out of 360. And we need to times that by pi r squared, so times pi times 32 squared. Put that all together and we'll get that the area of that will be 983 centimeters squared. Again, well done if you got that one. Quite a tricky fella. Okay, cheers.